Okay, previously we've talked about observational studies, and we said observational studies, and we're on page 27 of the notes, and we're going to be focusing on experimental design and components of experimental design in this video. And previously we said observational studies can be statistically significant. We also said that they are the most common type of way of collecting data, and that surveys are part of them. However, the limitation on observational studies is that they are unable to prove causation. Only well-conducted experiments have the power to prove causation. The biggest difference. Observational studies, we're getting someone's opinion, we're observing what they are already doing, all right? Whereas in an experiment, we assign the treatments. We impose treatments on them. They didn't get to choose their treatments. So observational studies, we have randomization, absolutely. We randomly select the people. In an experiment, we randomly assign the treatment. An observational study, they generally have, you might consider that they chose their treatment. They chose which breakfast cereal to eat. In an experiment, we would randomly assign them a cereal to eat. Now, experiments do involve volunteers, all right? We have to, we can't make people do things. So experiments do involve volunteers. So we have volunteers, but they don't get to choose which cereal that they're going to eat for breakfast. You're going to get grape nuts, you're going to get frosted flakes. Which one tastes better? And we randomly assign those treatments. So an experiment is in a controlled study that requires treatment be assigned to one or more groups. We always have to have some sort of comparison, although we can sometimes use ourselves as a comparison, and we'll talk about that sometime next week. And experiments must satisfy the idea of control, random assignment, and replication. All right, so let's talk about random assignment. Random assignment is the principle of randomly assigning subjects or experimental groups to various treatment groups. In other words, and by the way, a subject is a human, experimental unit is something other than a human. All right, these are the things that we're going to experiment on. And we assign them treatments, or we impose treatments. We use random assignment to equal out or mitigate differences in the subjects. So basically, when I talked earlier about flipping a coin and for choosing dodgeball teams, that's the idea of random assignment. We know we can't equalize all the differences between people. Because we can't equalize those differences, we have to use randomization. We need at least two treatment groups. One may be a control group. Please note, random selection and random assignment are not the same thing. Random assignment, I'm assigning you a treatment. Random selection is I randomly selected you from the population because you make up a good study part. In science, we talk about replication is performing an experiment over and over and over again and getting the same results. Well, we're working not in a laboratory. We don't have perfect chemical measurements. Matter of fact, when we're talking about human beings, if you look around the room, there's no one like you. You're unique, you're special. You're one of a kind, as your parents would say. I think you're weird. That's another way of expressing it. But they have a positive spin, I have my spin. But basically, because everyone is different, we're going to react differently. The chemicals should react the same every single time. But human beings, from one human being to another human being, we react differently. So replication in science says we get the same result every time. Replication in statistics means we're going to apply the treatments to several subjects, at least more than one, so that, at least two subjects, if not, and many more is better. We're going to apply it to more than one subject so that we can generalize for the population, all right? Because, so we have to have more than one. So replication is we're going to have more than one person eat grape nuts, as the case may be, all right? Control. I love the concept of control, but I gave that up 32 years ago. That's called marriage when that went away. But control means we know that there are outside variables that are going to impact the study, and we want to isolate those variables. For instance, on the breakfast cereal, generally speaking, breakfast cereal is better immediately after you pour the milk, not 20 minutes after you pour the milk and it's become soggy. So basically, we would want to control for things like that. So here's a list of things that we like. Here's a list of ways we control things. Blocking, blinding, and control groups. Not the only things that we need to use for control, like I said, on the breakfast cereal, but a couple things. So blocking, first off, I kind of get mad at statisticians sometimes. This is one of those times I'm a little bit frustrated with them, because blocking is exactly the same thing as stratifying. Okay, so blocking is the same thing as stratifying, but you say blocking for experiments and stratification for surveys. Do not interchange the terms. If you do, you're going to lose half your credit. So you block for experiments, you stratify for surveys. Please do not interchange those terms. So if they mean the same thing, that means, oh, so we block based on the variable that we think will have the greatest impact. And I'm like, absolutely. So for instance, if I believe that if we're doing a study on hormone therapy, I'm going to say, you know what, I'm going to block based on gender. I'm going to put the females in one group and the males in another group. So because I believe that they may react differently. So we block based on the variable that we think will have the greatest impact. If I believe that income has an impact, I may want to block on income. If I believe age has an impact, I may block on age or body type, etc. Blinding is another way to eliminate sources of bias. And in this case, blinding is the subject or the data collector or both are unaware of the treatment they are receiving. If both are unaware, it's double blind. If only one is unaware, it's single blind. If I'm giving two medications, it'd be very easy to say this is medication A, this is medication B. That's the way the containers are labeled. The person taking the drugs, they know they got medication A, but they don't know what it is. The data collector knows that the person got medication A, and they're saying, hey, they're improving. The person getting medication B is not improving. But the data collector just knows that there's medication A. They don't know what it is. In which case, both of them would be blind, so that would be double blind. We can also, the one people usually have trouble with is single blind, where the data collector doesn't know. So here's my example. If you put into a weight loss program and it involved exercise, I can tell you the subject is going to definitely know what exercise they're receiving. But when they came in to see if the data collector comes in and weighs them, they're not going to know what exercise the person received. So in that case, the data collector was blind, but the subject was not. And we can think of lots of instances where the data collector is not blind and the subject is. The data collector very well may know the treatment that's being given to the subject. Control group. Typically, a control group does not receive a treatment. We often call it a placebo. Oftentimes, when we give them a sugar pill, doesn't have to be a sugar pill. I mean, it doesn't mean that they're going to receive a placebo. It may just be someone not receiving a treatment. But the purpose of a control group is to provide a baseline for comparison. This allows us to determine whether the changes. This is a hugely important sentence. This allows us to determine whether the changes that are being observed can be attributed to uncontrolled four factors. All right. So, regardless what happens, I'm going to get older, and that's going to mean certain things will deteriorate. The question is the medication I'm taking the medication and I'm still deteriorating because I am getting older. However, is it slowing whatever negative effect? Is the arthritis pain diminished as a result of the medication, even though times of the year it's cold and the arthritis comes back harder when it's cold? Okay. So the purpose of a control group is to provide a baseline for comparison. That's a huge, I would say that every single time. What's the purpose of the control group? To provide a baseline for comparison so we know whether or not the changes we are observing are due to the treatments or to an outside factor or an outside variable. Okay, so we've talked about that. And observational study versus an experiment. We'll go ahead and include that into this. So a study is to be designed to determine whether taking daily calcium supplements benefit women by increasing bone mass. So how can an observational study be performed? Well, remember, an observational study is that they've already doing this, all right? They're doing this on their own. Treatment was not imposed. And it can be also hospital records. So probably the easiest thing is to go to hospital records or medical records of women who have taken supplements and look at changes in their bone mass from the time they begin taking the supplements until some point in the future of the treatment. And the other thing you can do is you can just go out and go, hey, these women are leaving the doctor's office, are taking supplements, and we can measure their bone mass and continue to observe them, all right, to see if there's any changes. How could an experiment be performed? Well, we could take a group of 100 women of similar age and health status, place all 100 names in a bin and a mix. This right here is random allocation right there. That's my random allocation. The first 50 names drawn would receive the calcium supplements. When I have 50 names, that means those 50, that's replication. This is also replication. So 50 receiving the calcium supplements and 50 were receiving a placebo. A health professional would measure the bone mass of the women before taking the supplements, and then 3 years after the supplements were taken. 3 years was just a random number I chose. It could have been 6 months, 3 weeks, 10 years, or whatever. The bone mass of the women taking supplements would then be compared to those who had not taken supplements. This diagram, this is a map. It is not a solution by itself. This is a map of what you need to be writing out. Random allocation. How did I do it? I placed in a bin and mixed. My treatments. Treatment 1, calcium, 50 people. Treatment 2, placebo, 50 people. At the end, what did I do? I compared the bone mass at the end. All right, compared the bone mass at the end. This is my diagram that tells me of the things that I need to make sure that I've included. So what is more appropriate? Well, in the case of the bone mass study, which is what this is asking about, both are equally appropriate. It wouldn't matter. The only thing is the experiment can show causation, however, it would cost more money. The observational study is quick, easy, and fast, but it cannot show causation. But either one would be appropriate. However, the reason we don't always do experiments is because even though they can show causation and observational studies cannot, is because oftentimes it's too expensive or it's unethical. So here's some simple things on ethics. A study is designed to examine the life expectancies of tall people versus those of short people. Well, obviously, the response variable that we're interested in is life expectancy, all right? Well, that's my response variable, and my explanatory variable is height, and my treatments are tall and short. Well, remember, I have to assign treatments in an experiment, and I can't very well make you tall, and I can't very well make you short. I mean, I could, but that would be really unethical. So consequently, an experiment would not be appropriate. However, I could just sit there and perform an observational study and go, how long do tall people live versus how long do short people live? And in general, short people tend to live longer. That's what the observational study indicates. Does it mean they're healthier, or does it mean there are other things happening in life, as in tall people or bigger targets? I don't know, just putting that out there. So a study is to be designed to examine GPAs of students who use marijuana regularly and those who don't. Which is more appropriate, an observational study or an experiment, and why? Well, Smoking marijuana as a youth is illegal everywhere. So that makes it unethical. So regardless how you feel about things, it'd be more appropriate from an ethical standpoint to observe, to measure, to do an observational study. We really cannot impose that someone be forced to smoke marijuana for ethical reasons. And some people are like, well, what about in Colorado? And I think that's a very fair statement. Well, in Colorado, marijuana is legal. And so let's just say we're talking about adults as opposed to students. This would still be unethical. You're like, well, but it's legal. And I was like, well, cigarettes are legal too. Would it be ethical for me to require that you smoke 2 packs of cigarettes? And the answer is, well, no, I guess it wouldn't. So the same thing here. For ethical reason, an observational study would be better, all right, than an experiment.